Imagine trying to secure a computer system where the intelligence isn't just sitting in one easy-to-find central brain, but is literally scattered everywhere. We usually think about cybersecurity as, building taller and taller walls around a single monolithic application. But what happens when you have to govern an entirely new kind of alien intelligence, one that operates across different models, agents, and tools all at exactly the same time? In this explainer, we're looking at the architecture of Warden. It's a security system that tackles this massive problem of governing non-monolithic AI by pulling inspiration from a very unexpected place: developmental biology.
So, Michael Levin, he's a researcher at Tufts University who studies developmental biology. He really gets to the very heart of this problem. He looks at how collections of cells, none of which individually understand the whole organism, somehow manage to cooperate, heal, and build complex bodies entirely without a central brain micromanaging them. Think about it. Biology doesn't keep a database of every single way a limb could possibly be injured. Instead, it just knows what a healthy state looks like, and it constantly works to restore that target state. Warden borrows this exact biological philosophy for cybersecurity.
Okay, let's dive into this fundamental shift in thinking. Traditional software architecture relies on monolithic intelligence. There's one application, and inside it is the logic, the brain. Everything else is just a dumb pipe or a sensor. But Warden relies on multi-scale intelligence. Actually, scratch that concept of a central brain entirely. With Warden, there is no single component you can point to and say, that is the intelligence. Instead, different competencies operate at different scales, all the way from local agents up to system-wide policy observers.
Here is the roadmap for our journey today. We'll cover 1. Biology's lesson. 2. Chasing homeostasis. 3. Navigating state spaces. 4. Intent versus consequence. And finally, 5. Governing the collective. Let's get into it.
Section 1. Biology's lesson on multi-scale competency. So Michael Levin talks about something he calls cognitive glue. In biological systems, competent parts solve problems locally, while larger collectives solve different problems at a higher scale. And communication? That's the glue that binds them all together. Warden uses this exact same approach. The scanner sees one world, the network operations center sees another, and the terminal sees yet another. They don't collapse into one single central controller. They share information to create a higher-order awareness.
Warden essentially takes this biology lesson and forces pure philosophy into executable code. It uses 3 distinct mental models, which is kinda wild. First, from Carl Jung, it takes the shadow, meaning it runs parallel, competing interpretations rather than forcing one unified voice. From Ken Wilber, it takes structure, understanding that an agent exists inside a workflow, which exists inside an infrastructure. And from Michelle McDonald, it takes awareness, meaning disciplined observation. Warden observes a signal and preserves it before rushing to interpret or act on it, because observation is not interpretation, and interpretation is definitely not authority.
Moving on to Section 2, Chasing homeostasis, not signatures. Look, traditional cybersecurity is an exhausting game of endless signature detection. It waits around for a known attack signature, a bad IP address, a known malware hash. But against autonomous AI, trying to enumerate every possible future attack is just a losing battle.
So the primary objective has to shift to what we call operational homeostasis. Just like that biological tissue we talked about earlier, Warden doesn't need to know exactly how it was perturbed. It just needs to know that it was perturbed. There's an acceptable region of system state. Services are functioning, identity is coherent, trust is within bounds. When something knocks the system out of that healthy zone, Warden responds to pull it back.
The absolutely crucial point here is that Warden is constantly measuring the multidimensional distance between what is happening right now, the current state, and what normal operation looks like, the expected coherent state. It's constantly asking, has the system moved away from its acceptable state, and can I figure out why?
Which brings us perfectly to Section 3, Navigating Warden's State Spaces. To maintain that coherent operational homeostasis we just discussed, Warden has to develop spatial awareness across several distinct dimensions at once. Let's take a rapid-fire tour through these state spaces.
First up are network and identity spaces. Warden monitors the basic flow of data to define exactly who is communicating, and it verifies the cryptographic identity of who or what claims to be acting. It grounds the basic flow of communication into definitive actors.
Next, we cross into policy and trust spaces. Policy space defines the strict boundaries of what that actor is actually permitted to do. Meanwhile, trust space measures the runtime confidence the system should place in this specific interaction at this exact moment.
Then, temporal and provenance spaces act as Warden's memory. Temporal space defines how the system state has changed over time by comparing present activity to historical baselines. Provenance space defines the exact origin of an instruction or artifact. A security system without memory only sees right now, but these spaces give Warden crucial history and origin context.
And this brilliantly illustrates why you cannot just rely on a simple good/bad binary in modern security. No single coordinate answers the question. An actor occupies the network, identity, policy, trust, and temporal spaces simultaneously. Warden has to connect them all. It's evaluating the actor's trajectory across a multidimensional space to monitor and maintain that operational homeostasis.
To see how this works in practice, picture an agent. Let's call it Warden Scan. Now, it's reporting a healthy local state, and its declared intent is just simple maintenance. But its observed action across the state spaces is credential discovery. Because Warden connects these different layers, the collective decision is immediately flagged for review. Much like a rogue cell in biology, the agent might be locally healthy and fully functional, but it has become globally misaligned.
Section 4. Separating intent from consequence. This brings us to a frankly incredible accidental discovery the creator of Warden made. He was originally just trying to fix a customer interaction flow, but it fundamentally changed how Warden governs AI.
The problem was that an AI model could understand what a customer wanted, but translating that intent into actual network activity was messy and unpredictable. So the creator built an execution tree. Customer intent goes to the large language model for interpretation, but then it must map to a pre-existing, known operation, which then follows a strict, structured execution path. So the model was given the freedom to interpret, but the machine itself was rigidly bound to structured, known paths.
And this led to the happy accident. When they tested it with adversarial manipulative prompts out in the wild, the system literally didn't break. Because the model was trained to map inputs to known operations, it often took bad, malformed language and essentially normalized it back into valid operational behavior. Language security was totally separated from machine consequence. The model learned a vocabulary of permitted action, and the execution tree prevented that language from directly hijacking the infrastructure.
So, the huge takeaway here is that an AI can definitely be manipulated linguistically. It might say something strange or misunderstand a prompt, but refusal to answer a bad prompt is just linguistic. Warden ensures that the machine doesn't automatically inherit the AI model's mistake. It cares about operational consequence. It totally separates what the model understood from what the machine actually did.
Section 5. Governing the AI Collective. Let's see how all of this builds our big picture. Warden isn't some giant puppeteer trying to dictate every single keystroke of an AI agent. Instead, it acts a lot more like a regulatory nervous system.
We touched on this briefly earlier, but it is so vital. Local competence absolutely does not equal global alignment. A rogue AI doesn't suddenly become stupid. It might have perfectly valid credentials, accurate local information, and extremely high reasoning capability. It remains incredibly competent. But just like cancer is a breakdown in coordination where a competent cell stops cooperating with the whole organism, an AI becomes a massive threat when its local goal separates from the system's overall policy.
That is exactly why Warden uses substrate-independent governance. Basically, that means it does not care if the actor is a human, an automated script, a language model, or some totally unknown autonomous agent. It asks the exact same fundamental behavioral questions across those state spaces we mapped out. What can it perceive? What can it influence? Does its stated goal match its observed trajectory? And is it cooperating with the larger system? Which leaves us with this final thought to ponder as we look at the inevitable future of cybersecurity and AI. As intelligence becomes totally non-monolithic, spread across countless capable agents and nodes, should we keep exhausting ourselves trying to build one impossibly smart central guard, or is it time we learn how to govern the collective itself? Thanks for joining me on this explainer. I really hope this completely changed how you look at the future of digital immune systems. Keep exploring, and I'll see you next time.